Okay, so the last unit we do in Chemistry 30 is Organic Chem. And this first video I have for this is just what we would start with, which is identifying organic compounds, naming the alkanes, alkenes, and alkynes, and also to be able to draw them. So I included some old diploma questions that go straight into knowing this information, and I will cover some of the theory behind it as we go. So the first one is knowing an organic compound. So first off, it will contain carbon. So carbon makes it organic, but there's a few compounds that we are going to rule out. And one is you're no longer organic if you're directly bonded to a metal. So we can take this one out. There's also a few that we look out for, and for instance, the CO3 negative compound, or -2, that one is not going to be organic if we're contained. So we have a metal, but you also have that CO3 -2 ion, so not organic. Number 7 has a metal, but the CN combination for the ion, it's also inorganic. And the last one we're going to look out for is oxides. So carbon monoxide is not organic. So the remaining are, so if you have a halogen connected to your carbons, that's fine. Hydrogens often fill it up, that's okay. Number 4, that's good too. And carbons with hydrogens are what we often see. So this first one would be 1, 3, 4, 6. Looking at this next one, being able to identify this. So the first part, knowing that there are no double or triple bonds, it's all single bonds. So if it's all single, it ends in A-N-E. It's going to be an alkane. So far we have nothing to rule out. So we're going to keep going. When you're naming, you want to identify your longest parent chain. So where you have, starting from this end, 1, 2, 3, 4, 5, 6, 7, 8 carbons. Then it's not always a straight line. So I went this way to get to 8. But you could go, if it was going this way made it longer, we're just looking for the chain that gives us the most. So it's not always a straight line. So 8 carbons is your longest chain, and 8 would give you octane. So same thing, we are able to rule out this one here because this one's saying hexane, and hexane means 4. The rest say octane. I'm sorry, hexane means 6. 8 is octane, so we're going to keep going. Now when you're numbering your carbons, you want to start numbering from the end that will give you the smallest number with the first branch. So I'm going to number from left to right. So this would be carbon 1 and this would be carbon 8, because that means on carbon 3 I get my first side group, and then on carbon 4 I get my second side group. If I started 1 on this side, it wouldn't be till 1, 2, 3, 4, 5. I wouldn't see a side group until carbon 5. So that would be going the wrong way. And of course, that is a distractor. So we're not picking that one. So this one on carbon 3, that is a methyl group. On carbon 4 is an ethyl group. So, oopsie. When we're looking at that, methyl alphabetically is after ethyl. So you want to name ethyl first. So that is leading us to number 4. So technically we would be able to draw this out if they gave us the name for A or B, but when you're naming your side groups, right, these branched groups, you need to name them alphabetically. So where you can rule out A, your answer is B. Looking at this next one, this is bringing in your term saturated and hydrocarbon. So to be a hydrocarbon, you contain hydrogens and carbons. To be saturated, every carbon is bonded to as many hydrogens as it can. If you're not saturated or unsaturated, that just means you have a double or a single bond somewhere within your chain. And that takes away the amount of carbons or hydrogens you can bond to. So for instance, this first carbon, instead of being able to bond to 4 hydrogens and be saturated, it can only bond to 2 other hydrogens. So it is unsaturated. So when we're looking at this, you need an alkane. Only alkanes, A-N-E, are saturated. As soon as you have an alkene, which is what this one's showing, or an alkyne, which is a triple bond, you're no longer saturated. So we can rule out B, and all I'm doing here, I'm not even looking at the full name, I'm just looking at the ending. We can rule out B and C because that's indicating double bonds, and D because that's a triple bond. Non-ane means we have an alkane. So here your answer was A. Now the other part that comes in often is knowing and comparing boiling point. The biggest part here, or the biggest machine that allows you to separate hydrocarbons, is fractional distillation. So if you are doing that, you are separating hydrocarbons by boiling point. Your lightest ones, or your lightest hydrocarbons, would go up first and be able to separate first. Then the ones with a higher boiling point, that takes longer. So when you're looking at these, we're definitely taking a look from the size. So butane, ethane, heptane, and methane. They all have single bonds. Butane would have 4 carbons, ethane would only have 2, heptane would have 7, methane only has 1. So to have the highest boiling point, you are going to be the biggest compound, and heptane would be the biggest without drawing the whole thing out, just because they all have 7. This question here is showing that you also understand the term isomer. So again, there's lots of information at first, but then it starts to become very repetitive. So to be an isomer, you want to have the structural formula, the empirical formula, C5H10. So that's all you want. So when you're looking at these, and I might just do some quick line diagrams to figure it out. If you have pent-2-ene, pent means you have 5. So if I do a line diagram, I have 1, 2, 3, 4, 5. And on carbon 2, I'd have a double bond. Now I have to remember how to fill in my hydrogens. So for now, pent-2-ene means I definitely have 5 carbons. So that part's fine. That was a check mark. And then I need to figure out my hydrogens. So this carbon on the end would have 3 hydrogens, right? Because if you don't see it, you're bonded to as many as possible. So we'll have 3 hydrogens here. This second carbon in, it has 3 lines going from the point, so it can only bond to 1 other hydrogen. Same thing with carbon 3. Carbon 4 can bond to 2, and carbon 5 can bond to 3. So with that information, we want to add them all up. So we have 3, 4, 5, 6, 7, 8, 9, 10. So we know number 1 will be an isomer of C5H10. So looking at the next one, and we can easily change pent-2-ene to pent-2-ine by adding in this triple bond, which takes away these 2 hydrogens. So if we have 2 less hydrogens, this one is not going to be an isomer. Next one, cyclopentane. So cyclo means you're all connected. Pent again means 5. And then every point bonds to the max number of hydrogens. So this top point can have 2 hydrogens, and well, all of them can have 2. So that would be 10. So cyclopentane would definitely be working out. Methylpropane. So already that's a problem. We won't have enough carbons. So let's take a look why. Methylpropane would look like this. You have a carbon here, carbon here, carbon here, carbon here. I'm not even going to deal with the hydrogens because that's not enough carbons. We need 5. So methylpropane is not one. Dimethylpropane, dimethyl. So when it's propane, we can't add on carbon 1 or 2 because it will no longer be propane. It would become butane. So we're going to add the next methyl group on the middle carbon because it's 2 methyl groups on carbon 2. So that's now 5. Now we need to count hydrogens. So all these N carbons can bond to 3 hydrogens. So we'd have 3 hydrogens here, 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 and here. And the carbon in the middle has 4 lines coming across out of it. So it can't bond to anything else. So if you add these together, it's 12. That is too many. So it's not going to be that one. Now looking at ethyl cyclopropane. So propane, if it's cyclo, means that you're all connected, so like a triangle. Ethyl means you have 2 carbons coming off. So we have 1, 2, 3, 4, 5 carbons. And now let's count out our hydrogens. There would be 3 here, 2 here, 1 here, 2 here, and 2 here. So 5 plus 5 is 10. Number 6 works. And your last one, methyl cyclobutane. Butane is 4. Cyclo means they're connected. Methyl, you just have to place a methyl group somewhere on there. And then that's 5 carbons. So let's count the hydrogens. There'd be 3 on this carbon. There would be just, sorry about that. There would have just been 1. That's okay, we can keep going here. There would have just been 1 on, let's just go back. So this, now my pen doesn't want to work. There would have been just 1 on the 1 connected. So we have 3, 1, and then 2 on the rest. So it looks like we would be including that one as well. So that list, even though I don't have it anymore in front of me, looks like it would have been 1 cyclopentane. Oh, I already am forgetting what I crossed out. But I hope you got it. I hope this is somewhat helpful. I might end up doing this one more time. If this did help you at all, please like and subscribe to this channel. Thank you.